solving inequalities with addition and subtraction similar to and different from solving equations with addition and subtraction? Think about this question during the lesson. The baggage weight limit is 50 pounds for the airline that Raul is using. Raul's first bag weighs 38 pounds. How much can Raul's second bag weigh without going over the limit? Is there more than one possible weight for Raul's second bag?
Select your answer.
The limit of 50 pounds means no more than 50 pounds. There are many possible weights that are no more than 50 pounds. This symbol for less than or equal to can represent the phrase no more than. Write an inequality to represent the situation. The weight of the first bag plus the weight of the second bag is less than or equal to the baggage weight limit. Which of these quantities are known and which are unknown? You know the weight of the first bag, 38 pounds, and you know the weight limit, 50 pounds. You don't know the weight of the second bag. That's what we want to find out. Let P represent its weight. We'll solve this inequality the same way we would solve an equation. We can use the inverse relationship between addition and subtraction to isolate the variable. The subtraction property of inequality is like the subtraction property of equality. Subtracting the same number from both sides maintains the inequality. The solution is P is less than or equal to 12. We can use a number line to show all possible solutions to the inequality P is less than or equal to 12. 12 is the greatest possible value of P. The second bag can weigh at most 12 pounds. It can also weigh any other amount less than 12 pounds. The number line shows the solution of the inequality. If the second bag weighs 10 pounds, the total weight is 38 plus 10 is equal to 48, which is less than or equal to 50. How is the real-world answer different from the solution shown? In the real-world answer, the second bag must weigh more than 0 pounds. For example, -3 is a solution because it is less than 12. But you cannot have a bag that weighs -3 pounds. Now you know how to use addition and subtraction to solve inequalities.
Kyoko has completed 26 hours of community service. Her goal is to complete at least 90 hours this semester.
Let's look at Kyoko. And she has 26 hours of community service. Her goal is to complete at least 90 hours. So her inequality we're going to use, H shows us here, stands for how many more hours. So H is that amount of hours that she needs to complete her goal. So H plus a number is going to be greater than or equal to or less than or equal to. So at least tells us that it can be a minimum. That's what the word at least means, minimum. It can be, her goal is to be at least 90. So that tells us that whatever hour she does has to be greater than 90. And the at least tells us that's the minimum. So the amount of hours she does could also equal 90. So that's why we have a greater than or equal to symbol. Now we have to use the amount of hours she already completed, which was 26 hours. So now that we have our inequality, h plus 26 is greater than or equal to 90, we need to solve this inequality. So now we're going to take the 26 and we are going to subtract it because that's the inverse of the addition here. We're going to subtract the 26 on both sides of our inequality, and this will cancel and we're left with h, and then 90 minus 26 is going to be 64, and then we keep our greater than or equal to symbol there. So h can be any number of hours that is greater than or equal to 64. So she needs at least those 64 or more hours to meet her goal of at least 90 hours. Now we're going to graph our inequality. So our inequality was, let me just rewrite it. It was h is greater than or equal to 64. And so now we need to move, h is greater than or equal to 64. So we move our point to 64, which would be about there, 64. And then we're going to have a closed circle because it's going to include the number 64. So we're going to have a closed circle on our point, and then the direction of our arrow is going to be to the right because it's any number greater than 64, or it could also equal 64. So that's why we have our closed circle and it goes to the right.
The weather forecast predicted that the evening temperature could get as low as -12 and 5/10 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7 and 5/10 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature, T, have been?
Write an inequality to represent the situation, then solve as you would an equation. So the inequality they have is T, which represents the temperature, minus the 7 and 5/10 degrees that it dropped, and that's negative. That's why there's a minus. And that's going to be greater than or equal to the -12 and 5/10 degrees Fahrenheit. And the reason it is greater than or equal to is because it says the temperature could get as low as, which means it cannot get lower than the -12 and 5/10. So it can get, so that's why the temperature here could be greater than or equal to that -12 and 5/10, because it could be equal to the -12 and 5/10, or it could be a greater number, which would be more than that. So now let's look at our inequality. And to get the T by itself on one side of the inequality, we're going to treat it like an equation and do the inverse of subtraction, which is addition. So addition of the 7 and 5/10 on both sides is shown here. And then you're left with T is greater than or equal to -5. So the -5 here on the number line is represented here. And it's a closed circle because it includes -5, and it could be a number that is greater than -5. And so the number line goes to the right. So the afternoon temperature could have been -5 degrees Fahrenheit warmer or greater. So that temperature could get higher than this -12 and 5/10, but it should not get lower than that because it says it can get as low, which means that's the minimum.
The speed limit on a road drops down to 15 miles per hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives around the curve. He never drives above the speed limit. What speed was Mr. Gerard driving before the curve? Graph the solution.
So let's identify this inequality. So it says the speed limit on the road drops down to 15. So that's going to be per hour. So 15 is part of our inequality. Let me write this down. So we have 15. And then it says Mr. Gerard slows down by 10 miles per hour as he drives around that curve. So we got 15 and we got 10. And then it says he never drives above the speed limit. What speed? He never drives above the speed limit. What speed was Mr. Gerard driving before the curve? So the speed limit drops down to 15 miles per hour around the curve. So it tells us he never goes above the speed limit. So the speed limit is 15 miles per hour around the curve. But the question is, what was he driving before he hit the curve? So we have the 15 miles per hour, which is the speed limit for the curve. And then we have that he slowed down to 10 miles per hour as he drives around the curve. 15 is greater than the speed that he was going. So we have greater than because it says he never went over the speed limit. And so we have his speed limit. Let's just put an S for his speed because we don't know exactly what his speed was before he started going around the curve. So we're going to use S as our variable. And then we're going to have to subtract from whatever he drove before the curve minus the 10 miles that it says he drove around the curve. So this is how fast 10 miles per hour around the curve. And so we're going to have to take away that 10 miles from whatever speed he was driving before the curve. But again, we know that it was not greater than 15, but it could also equal 15 because it says he didn't go over it. That doesn't mean he wasn't driving the speed limit. So he could have been driving 15 miles per hour or less than 15 miles per hour. So we can now use this inequality and solve it. And so we are going to add 10 on both sides of our inequality. And this will cancel out here. And then we have 25 here is greater than or equal to his speed. So Mr. Gerard's speed was 25 miles per hour or less before he hit the curve. Now it asks us to graph this on the number line. So he was going 15. No, let's go 25. 25 miles will be about there, I guess. 24, 25. Yeah, somewhere in this area. And it's going to be a closed circle because it includes the 25 miles per hour. He was driving at least that or less. So our arrow is going to move to the left because it says 25 miles per hour or less. And that's how you would graph that inequality.
Solve the inequality negative 2/3 is greater than x minus 1/2. Then graph the solution.
Negative 2/3 is greater than x minus 1/2. To solve, we would take the minus 1/2 and we're going to get our variable by itself by adding 1/2 on both sides. And then negative 2/3 plus 1/2 is equal to negative 1/6, and that is greater than x. And then to graph it, our point is open because that does not have that equal to underneath it. So it does not include the negative 1/6. So it's going to be an open circle. And then we're going to move to the left because x is less than that negative 1/6. So we're going to be moving to the left.
Solve the inequality negative 5/8 is greater than or equal to n minus 1 3/4. Then graph the solution.
I am going to just rewrite it over here. Negative 5/8 is greater than or equal to n minus 1 3/4. So we're going to bring the minus 1 3/4 over to the other side of the inequality by adding 1 3/4 to both sides of the inequality. Cancels out here. So we have n left by itself on that side. And then we're adding the negative 5/8 and 1 3/4. What we do know about fractions is that the denominators must be the same when we're adding. So we need to make sure that both are the same. So the denominator of 8 and 4, I'm going to make the 1 3/4 have the same denominator as 5/8. So I'm going to make it have an 8. So I need to multiply it by 2. But first I'm going to make it an improper fraction. So I'm just going to be rewriting it over here for more space. And so this is going to be adding, and then we have 1 3/4. So 4 times 1 is 4 plus 3 is 7. So that would be 7 over 4. And again, I need to make that be the same denominator. So I'm going to multiply that by 2. And so now I'm going to have 14 over 8. So 14 over 8 plus minus 5/8. So now I can add this straight across. My denominator stays the same. So I have negative 5 plus 14. And so 14 minus 5 is going to give me 9. And so we have positive 9/8 because my 14 is greater than my negative 5. So my answer will be also positive. And so we have 9/8. And I'm going to make my 9/8 that's going to be greater than or equal to the n. And I'm just going to make that a mixed number. So we got to divide 8 into 9. 8 goes into, let me write it over here. 8 goes into 9 once. So we have 8 and 1/8. Oh, Lord help me. Sorry. That should be a 1. My apologies. That is a 1. So we have 1 and 1/8. And so now when we go to graph this, and I just want to rewrite this at the top for good measure. So we have 1 and 1/8 is greater than or equal to n. So now we need to graph that. So when we look at our number line, we're going to go to the positive side for the 1 and 1/8. So it's going to be past the 1 because 1/8 is a fraction greater than 1. So we're going to be about here-ish, right? And then it's n is less than this number. So my arrow is going to be going to the left. And then this is going to be an closed, and I'm drawing it this time instead of using the sliders, but this is what my graph will look like to show the inequality, the solutions for this inequality.